The total mass of a cyclist and her bicycle is 70 kg. The cyclist is riding with constant power of 180 watt up a straight hill inclined at an angle alpha to the horizon. So the angle with the horizontal is alpha, and it was giving a constant power of 180 watts. So that's really important information. Sine alpha equals to 0.05. At an instant when the cyclist speed is 6 meters per second, our acceleration is minus 0.2 meter per second squared. There is a constant resistance to motion of magnitude F Newton. So we have to find out the value of F. So at first, let's draw a figure to understand the scenario here. So say, for example, this is the cyclist and her bicycle, and she is moving up a straight hill. So that means she is moving in upward direction. So she is applying some amount of driving force. So let's consider dF, and her component of weight will act in downward direction. That's mg sine alpha or theta. So let's consider theta, the angle. Oh, sorry, the angle is given as alpha. It's given as alpha, so sine alpha. And there is a constant resistance to motion of magnitude F Newton. So resistance to motion F Newton, and the value of F is, we don't know yet, we have to find out in question. So in question A, the total mark is 4. So that means we have to do 3 to 4 steps to find out the final answer. And also the acceleration is given as minus 0.2 meter per second square. So that means it's actually decelerating in upward direction. So what we can do here, as we know the power, constant power of 180 watt, and we know the speed, we can find out the corresponding driving force. So we know the formula P equals to FV. Now you always have to remember, when you are considering a constant power, the corresponding force is actually driving force. The corresponding force here is actually driving force. So let's write down the equation as power equals to driving force multiplied by velocity. Power equals to driving force multiplied by velocity. The power here is 180 watt. Driving force, we don't know yet. And velocity is 6 meters per second. So driving force here is 30 Newton. So we have got the driving force. Now let's make an equation. So the object was accelerating, so downward force. So as the object was accelerating, so in upward direction, it was applying driving force. So driving force minus in downward direction component of weight, so mg sine alpha, plus resistive force, we don't know the value yet, so equals to mass into acceleration. Mass into acceleration, Newton's second law. So driving force is 30, mass is 70, the value of sine alpha is 0.05. Mass is 70, acceleration is minus 0.2. Now from here, make F as the subject. If you do the calculation, the value is of F is going to be 9 Newton. So that's the resistive force. So I think you have understood. It's not that difficult. Now in question B, find the steady speed that the cyclist could maintain up the hill when working at this power. So that means when it is working at that power, what can be the corresponding steady speed that the cyclist could maintain? Okay, so again we can apply. So power equals to driving force multiplied by velocity. So power was 180 watts. So the driving force here is 180 divided by V. In the question, they're asking about the steady speed that the cyclist could maintain. So we will consider that V as the steady speed that we have to find out. So now here equation will be, let's go back to the figure again. So the driving force that's gonna act in upward direction, and resistive force and component of weight is gonna act in downward direction. Now, as they're talking about steady speed, so the resultant force is gonna be 0. Resultant force is gonna be 0. So that means in upward direction, driving force, and in downward direction, mg sine alpha and the resistive force. Sorry, resistive force, F. So the equation is gonna be driving force equals to F plus mg sine. Driving force 180 by V. Resistive force we have found out as 9 Newton in the previous question. Mass was 70 kg, so 70 into 10 into value of sine alpha was 0.05. So from here, make V as the subject. The value of V is going to be 4.09 meter per second. 4.09 meter per second. So that's the steady speed that the cyclist could maintain while applying a power of 180 watt. So that's all about question 4. So let's move on to question 5.